Go. Okay, so moving on to the next slide. So we had so basically in the previous slide, we saw a property of square roots. Here's some others. Basically, what's nice about taking square roots is that the square root of a product is the product of the square roots. In other words, taking a square root, it's compatible with multiplication. That's really what this is saying. And it's also compatible with division. That's what this is saying. The square root of a quotient is the quotient of the square roots. That's what this is saying. Okay? And again, of course, you have to assume b here is positive. You'd never divide by 0. And we're assuming that the numbers here are all at least non-negative. We're not talking about complex numbers. That's when you take the square root of a negative. That's where things get fun. But unfortunately, we're not there yet. Hope we get there soon. But that's what these properties are. The next line here, I'm not proving this statement. If I want to prove this, I would have to show this equation held for every a and b non-negative. This equation is really just verifying it for the case when you have 25 and 16. So on the one hand, from previous slides, although even without that you should know, the square root of 25 is just 5. Okay, let me mark this up. Okay, the square root of 25 is equal to 5. We did see that from before. Again, it's because 5 squared is 25 and 5 is non-negative. Square root of 16 we saw is 4, because again, 4 squared is 16 and 4 is non-negative. So this product here is 5 times 4, which is 20. Well, what about over here? Well, 25 times 16, that's just 400. So the square root of this product is equal to the square root of 400. That turns out to be 20. So you have this product equal to 20, and 20 is also equal to this, so we get this equality. So again, this is just at least illustrating why this is true in a special case. It's not a proof of it, though, because we don't know what a and b are. But I really hope this makes sense. And the quotient, it's similar, but I'm going to skip over that part. Okay. All right, that's what square roots. So that's an introduction to it. What I want to do now is look at simplifying them. And to simplify square roots, we have to know what perfect squares are. And that's what that's what slide is telling us. A perfect square is a number that's equal to m squared, where m is a natural number. Natural numbers in this course are the positive integers. So I listed some of these perfect squares. I mean, I can't. So for instance, 1 squared is 1. So 1 is a perfect square. 4 is 2 squared. So 4 is a perfect square. 9 is 3 squared. 9 is a perfect square. And so on and so forth. Of course, the list keeps on going and never ends. So we're not going to write down, well, we can't write down all perfect squares. There's too many. Okay? But the next one in this list would be 7 squared, which is 49, 8 squared, which is 64, and so on and so forth. That's what the perfect squares are. And so notice 0, oh wait, sorry, 0 is not a perfect square, mostly because 0 is not a natural number, even though 0 squared equals 0. Okay. Now, I want to get the simplifying square roots. But what does it mean for a square root to be simplified? Well, that's what this tells us. The radicand, remember, is what you're taking the square root of. So the radicand cannot have any factors that are perfect squares except 1. I mean, 1's going to be a excuse me, 1's going to be a factor of everything, of every number. So, you can't get around that. But if 1 is the only factor that's a perfect square, then the square root is simplified. Okay, that's a fun definition, I know. So let's see some examples of this. Well, let's look at the square root of 15. Well, is that simplified? I don't know. Let's look at the factors of 15. So we're looking at the factors. We get 1, 3, 5, and 15. So those are the only factors of 15. And if I probably should have a table here. Let me go back. Oh, there we go. But if you went back here, you would see that 3 is not a perfect square. It's not in this row here. Or in other words, it's not equal to some other natural number squared. Same thing with 5. 5 is not here. 3 is not here. 15 is not here. What am I trying to say? Well, I'm trying to say that, this is simplified, that the only factor of 15 here that's a perfect square is 1. Only 1 is a perfect square, so this is simplified. That's what I'm trying to say. Okay, that's one example. Let's consider now this one, square root of 20. So we want to know, is that simplified? Well, we have to look at the factors of 20. Yes, 1 is in here. 1's a perfect square. But notice 4 is in here, and 4 is a perfect square, right? 4 is 2 squared, right? So 4 is a perfect square. And that tells us 20 has a factor besides 1 that's a perfect square. I mean, 1 and 4, you can see here, are the only perfect squares. But this is not simplified then. Okay, so we have one that's simplified, one that we know is not simplified. Now you should probably be asking, okay, so we know it's not simplified. Well, how do we simplify it? Well, that's actually pretty easy. Well, idea at least. This is the process for simplifying one. Essentially, what you're going to do is you're going to take that perfect square, factor it out, apply this product rule, or I guess equation if you want to call it that, and then you repeat on what's remaining, the square root that's left over, if you can. So this is the process. Again, obviously you don't have to memorize this because it's in the notes, which I posted. But essentially you find that perfect square. Excuse me, that's not equal to 1. That's not 1. Factor it out. Square root of a product is the product of the square roots. And then you try to simplify the square root remaining. If you can. You may not be able to, but you might be able to. Okay, so that's the process. That's fun. Let's check it out. So here's radical 20. We're going to simplify that. Okay, so we already know 4, right, is a factor of 20. Okay, so what we're going to do then is we're going to factor it out. How do you factor it out? It's really just like what we did with polynomials, right? You have to divide to see what's left over. That's what I'm doing over here. And so we get 20 is 4 times 5. So because this is true, so we have that perfect square, that factor, we factored it out. Now the square root of a product is the product of the square roots. That's why I'm going from here to here. And what's the square root of 4? That's just 2. Right? Square root of 4 is 2. Again, that's because 2 is non-negative and 2 squared is 4. So we end up with this. So we went from here to here. So yeah, this is a little bit easier to deal with. Now the question is, okay, what about the square root of 5? You know, we have to wonder, is the square root of simplified, that remaining square root, is that simplified here? Well, let's take a look. Okay, this I just reproduced for convenience. Well, we know the only factors of 5 are 1 and itself. Okay, this might be a little beyond the scope of the course, but 5 is actually called a prime number, meaning only factors are 1 and itself. And also 5 is bigger than 1. 1 is not prime by definition, but anyway, so that's what 5 is, okay? But you can see that 5 is not a perfect square. It's not equal to some natural number squared. So because of that, square root of 5 is simplified. And so this is good. So here we have simplified the square root of 20 to be 2 times the square root of 5. So we're good. Okay, good. Okay, so that's good. Let me just pause the recording. We'll get to the next example. Don't worry. We just pause the recording.